What is CAP theorem? Acid, consistency, availability, partition tolerance, tech interview prep. Let's first understand what is CAP. Consistency. Every read receives the most recent write or an error. Availability. Every request receives a response, without the guarantee that it contains the most recent write. Partition tolerance. The system continues to operate despite an arbitrary number of messages being dropped by the network between nodes. Let's take another look. Consistency. Consistency means that all clients see the same data at the same time, no matter which node they connect to. For this to happen, whenever data is written to one node, it must be instantly forwarded or replicated to all the other nodes in the system before the write is deemed successful. Availability. Availability means that any client making a request for data gets a response, even if one or more nodes are down. Another way to state this, all working nodes in the distributed system return a valid response for any request, without exception. Partition tolerance. A partition is a communications break within a distributed system, a lost or temporarily delayed connection between two nodes. Partition tolerance means that the cluster must continue to work despite any number of communication breakdowns between nodes in the system. In theoretical computer science, the CAP theorem, also named Brewer's theorem, states that it is impossible for a distributed data store to simultaneously provide more than two out of the above three guarantees. Consistency as defined in the CAP theorem is quite different from the consistency guaranteed in ACID database transactions. What is ACID? Atomicity. Transactions are often composed of multiple statements. Atomicity guarantees that each transaction is treated as a single unit, which either succeeds completely or fails completely. Consistency. Consistency ensures that a transaction can only bring the database from one valid state to another, maintaining database invariance. Any data written to the database must be valid according to all defined rules, including constraints, cascades, triggers, and any combination thereof. This prevents database corruption by an illegal transaction, but does not guarantee that a transaction is correct. Referential integrity guarantees the primary key, foreign key relationship. Isolation. Transactions are often executed concurrently. Isolation ensures that concurrent execution of transactions leaves the database in the same state that would have been obtained if the transactions were executed sequentially. Isolation is the main goal of concurrency control. Depending on the method used, the effects of an incomplete transaction might not even be visible to other transactions. Durability guarantees that once a transaction has been committed, it will remain committed even in the case of a system failure. This usually means that completed transactions are recorded in non-volatile memory. Let's take one more look. Atomicity. Atomicity means that you guarantee that either all of the transaction succeeds or none of it does. You don't get part of it succeeding and part of it not. If one part of the transaction fails, the whole transaction fails. With atomicity, it's either all or nothing. Consistency. This ensures that you guarantee that all data will be consistent. All data will be valid according to all defined rules, including any constraints, cascades, and triggers that have been applied on the database. Isolation. Guarantees that all transactions will occur in isolation. No transaction will be affected by any other transaction. So a transaction cannot read data from any other transaction that has not yet completed. Durability. Durability means that, once a transaction is committed, it will remain in the system, even if there's a system crash immediately following the transaction. Any changes from the transaction must be stored permanently. If the system tells the user that the transaction has succeeded, the transaction must have, in fact, succeeded. #CAP, consistency, availability. What is CAP theorem? Acid, consistency, availability, partition tolerance, Tech interview prep.